Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Your database is probably the most valuable part of your application, and it can be terrifying to think of it falling apart. However, that's just a day in the average developer's life in many companies. In this episode, we're going to discuss how to make sure that your application database is more resilient. While this won't fix every potential problem, it will help to protect you from the most likely things that could go wrong. But before we get started, Will, what's been dataing your base? No, that just did not come out right. I don't know.
What's been dropping my indexes?
There you go. Yeah. Oh my goodness.
Well, we're on support week this week. So it's, you know how you start thinking about your work in terms of how many interruptions deep you are? Kind of like a stack depth. And I think I'm at like 5 now.
Okay.
Yeah, it's pretty rough. And our product is actually very stable. It's just that, you get a wave of stuff that hits, or you get new clients that have different expectations, or they got some weird data coming in and things shake through the system. So yeah, it's been a bit of a gnarly week. The other thing is that, I've been doing the 12-week year thing, where I have like basically quarterly goals. I have 12 weeks of, solid work on it. Then I have 1 week that's like the deloading week. That is this week. And that's been interesting because I hit most of the stuff that I intended to do. The stuff that I didn't was, I realized I needed to probably prioritize a little bit differently. So this seems like this is pretty workable. Like I got a lot done this quarter. So I'm definitely going to keep that practice. And I've been planning for the next quarter and, learning, from my learnings from the previous one, it's kind of changed the way I'm looking at it. And I'm doing a whole lot more deep planning on what I want to do. So it's pretty good. So how about you?
Well, I will be speaking at the Burrow.dev meetup in May. Got connected with their organizer and signed up for that. And I also submitted a talk to Codeland, the Code Newbie, one that I spoke at a couple years ago. They're still online only, but I went ahead and submitted anyway. It'll be kind of fun to do that. In other news, my friend meant to send me an inspirational scripture this morning, but typoed the reference. So I got Isaiah 30, verse 8 instead of verse 18. And verse 8 says, "Now go, write it before them on a tablet and inscribe it in a book, that it may be for the time to come forever and ever." Which is really funny because she's the friend who co-led the small group with me where we wrote the material that I'm turning into a book. And so I responded, I was like, telling me I need to get on it on that book. And she's like, "What are you talking about?" And so I copied the scripture and sent it to her that like she had sent to me. And she's like, "That should have been verse 18, not verse 8. I was like, well, verse 8 also applied. So I thought that was hilarious. In the best news of all, I am 1 pound away from my goal weight. Weighed myself this past weekend. I weigh every weekend. And 1 pound away, I hit my goal pant size. Went shopping Saturday and was very surprised when the pants I was trying on were too big. And so I tried a size smaller and I was like, oh, well, I have reached my goal. So that was cool too. With that in mind, I am adjusting my focus on my exercise and diet to be focused on tone. So rather than being focused on weight loss, I'm focused on toning up. I'll probably still lose a little bit more weight, as I do this, because I'm going to, once I get toned, then I'm going to start working on bulking up with muscle. And so the toning process will probably still lose a little bit of weight, and then I'll start bulking back up, and I'll kind of stay in this range. But it's kind of cool to be, like I said, 1 pound away from my goal weight. I'll probably hit that either this weekend or next. The weight loss has sort of slowed a little bit.
That was the thing I enjoyed the most when I did that, was like tweaking with the diet and trying to hit it, hit a goal and then adjusting to hit a different goal.
Yeah.
Yeah, and just all the measurement and actually seeing the progress
Mm-hmm.
was the coolest part. I really ought to get back to it, but I don't know. My schedule at the moment is not very conducive to anything.
Yeah. That's fair. That's fair. I'm kind of very picky about my time when it comes to that. I make sure I get that time in, amongst other things. So
Saving money is hard, especially when you pay for cloud databases.
Lucas Casares is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us here at Complete Developer Podcast, he focuses on helping you to not only establish a real plan for your finances, but also to take action on that plan so that you can live your best life.
Guys, investing in financial planning services, it really comes down to whether or not you can improve your finances. And with the help of Level Up, the compounding impact of making better financial decisions will easily pay for itself.
Level Up also has a unique pricing model that will help you no matter where you are in your financial journey.
And best of all, Lucas is a fiduciary for his clients. What that means is he's not here to sell you anything, but to guide you to a better financial solution.
And speaking of guidance, he's got a podcast, and it's called Techie Personal Finance Bootcamp. And in that podcast, he covers financial topics that you probably face as a developer. And he also interviews other IT professionals who share how they navigated their own careers. And he's got even more information at levelupfinancialplanning.com.
Your application's data is probably one of the most valuable and longest lived pieces of your application. When your application goes to the big bucket in the sky, as we'll put it in this outline, its data will likely live on, perhaps being migrated into another system that is itself waiting for its own eventual obsolescence. Such valuable data is unlikely to remain the sole property of your application for very long, no matter how much you try to keep other people in your company out of it. As a result, if you want your application to be stable, one of the main sources of problems you'll encounter is your very own database.
Yeah. Further, because databases hold such critical data and because they are the furthest in component in most application models, it's much harder to scale them effectively and safely. A small issue in a database can ripple outward, potentially crippling multiple applications. Besides the ordinary worries of things like network issues and hardware failures, the very way that databases tend to get used in modern apps can cause scaling issues. Making things even worse, many database stability and resiliency issues don't make themselves apparent until the system is already under load, making it very difficult to find problems before they occur. And many developers don't do a very good job of making sure that their code doesn't cause problems at the database level itself. Finally, the causes of many database issues is kind of transient and involves the interactions of multiple disparate systems and often includes timing considerations.
Yeah. Now, with all of that, there is still some hope. There are some realistic things you can do that will improve the stability of your database and interactions with it. These things will not only make sure that your database stays in a working state during your application's lifecycle, but they also make it a lot more likely that your application, which depends on the database, will not be as easily broken by another client of the same database. Most of these suggestions can be simply summarized as do less stuff on the main database server. But like most summaries, that's not quite enough to act on.
In this episode, we're going to discuss some things that you should start and stop doing in order to increase the resilience of your interactions with your application database. While these can't entirely prevent a catastrophic failure, what they can do is make it less likely that your use of the database is the cause. This can often still help your system be more stable while also making the worst offenders more obvious. In the aftercast, we're going to discuss some general principles of database stability and follow up with a discussion of some common areas where developers have database issues from an organizational perspective.
Cool. So first off, keep schemas backward compatible with a couple of versions of deployed applications. While it's very tempting to do things like deleting columns in a single state, that can cause a lot of problems and wreak havoc with the dogs of war. Wait, no, with application stability. You'll want to update the applications to use a column to no longer do so well before deleting this column.
Right. So if you've got code out in the wild, what you don't want to do is push an update that deletes a column that thing is dependent on, because it's going to break it. And you probably should do changes in such a way that anything that is accessing a column has to change before that column goes away. And by the way, this is also important to do with things like indexes and other things too, where it may have a performance impact, but not a, it just breaks things type impact. Columns are a really simple example, in fact, but there are other parts of the database that can really kind of jump up and bite you. I mentioned indexes. I've seen cases where somebody has removed an index that they thought was not needed because their app didn't use it, but there was some other app in the organization that did reach into that database. And when that other app reached in, it broke their main application, because it was basically locking a whole bunch of records and was not able to retrieve stuff quickly and get out.
You should also be cautious when adding columns, especially required columns, changing column types, or really renaming anything. That's a big pain. The old version of an application that accesses a database should be able to continue working until a new one is deployed and verified. Yeah, that's a big deal.
Yeah. And it's really easy to miss, right? Because you think, oh, well, I changed my code. It's like, yeah, but how long between when an update gets applied and when your code is actually rolled out and ready to go in production and being used? That could be part of your build process or your deploy process. It could take a few minutes. And if you're doing some kind of load balancing rotation, there's a lot of stuff that can really kind of weigh in here. And it's very easy to break a running app. So typically what I like to do is actually do a 2-phase thing. Yeah. If I'm going to delete a column, the first thing is I make the apps stop using that column. And then later on, I'll have something that basically reminds me, hey, you can kill this column now. This gets even nastier if you have multiple applications that are hitting the same database, because one application may need a change while other applications are not really ready to deal with that change yet. Especially if you've got different teams. Like if you have one team that's continuously deploying and they deploy daily or something like that, and you got another team that deploys every 6 months, your team that deploys daily cannot delete a column for an average of 6 months.
Yeah.
That may really play havoc with a lot of things that you want to do.
You really like that word havoc, don't you?
It is. Havoc actually means no mercy. In Latin. And that's exactly what this feels like, is being on the end, the pointy end of a Roman legion, because you're not getting out.
Oh. So next, be redundant over and over again, everywhere. It goes without saying that a single point of failure is simply an invitation for failure to just drop on by. Open door policy. This is often true of database systems used in applications. For a lot of applications, if the database server goes down, they ain't no application, y'all.
That's right.
You got to throw the y'all in there too. I mean, with the look.
Yeah, because that's when you know it's serious.
Y'all can't see my look, but I gave a look too, y'all.
That's right. Yeah. Your database server's gone. Your application functionality is missing like teeth at Waffle House. At a minimum.
Wow.
Yeah. You heard me.
For those not in the South, you want to explain that joke or just let it roll?
I'll just let it roll.
All right.
Get a Southerner to explain it. They'll do it pretty quickly. At a minimum, you should have a failover system available for your database and have data replicated to it if you're going to be doing anything critical in production. You should not rely on restoring from a backup unless you're comfortable with hours of downtime. I've seen people do this. Like, oh, we need this app for our company to run, and it's internal. It's like, okay, well, we don't need to have a failover server because we can get out a little cheaper, or I don't want to read this, I don't want to get a master's degree in Oracle/SQL licensing.
Oh, yeah.
And so they're just like, I'll just restore from a backup if something busts. But then you get enough data in there, the backup takes 4 hours and everybody's dead in the water. Been there, done that. Do not suggest it.
Yeah. And of course, it's always one of those things where if you're going to do that, you're not going to plan to do these updates over the weekend when nobody's in the office using that internal system. It's going to be like Wednesday morning or something.
Right, because you don't want to be in the office. I mean, and this will actually give you a bias towards having to work on the weekends or after hours too, right? Which is another reason not to do it, because that stinks.
This also means redundant storage and other infrastructure that supports the database is required if you're hosting it yourself. While you probably are better off in a lot of cases hosting your database on the cloud. Is it on the cloud or in the cloud? Tricky. That's a yeah, I'm not sure there. Message us. Let us know what you think. That's basically meaningless if a router failure makes your database unavailable.
Yeah. Another scenario that'll get you is if you're serving media, for instance, from a CDN or from a file system, hopefully not a file system anymore, and that goes down and you don't have any redundancy there. Well, it's still going to break your app.
Yeah.
You pull that value out of the database and that's great, but it points somewhere that it doesn't go.
That's why like iTunes copies, like I think your first, like your top, like your 5 most recent or 10 most recent, I think it's 10 most recent episodes. There was a big like stink in the podcasting community. Some of you guys know about this, but because of that, because like people thought they weren't getting like that, because iTunes was doing that, they weren't getting the usage data. And if you're using like one of the bigger name CDNs, then iTunes was sending that to them, but it wasn't like real time. So
right. Well, I remember when they changed that, we had a drop.
Yeah.
And that was early on. Mm-hmm. And I mean, we had a mild degree of panic.
Yeah, we did. And then we found out what was going on. And then the numbers came back. It's just we were checking real time.
Yeah. And now I don't know. It's been a month or two since I've even looked.
I get the emails every day and I'll check them periodically, maybe once a week when episodes drop. I'll look the next day and be like, oh, hey, how'd that episode do on, the day it came out? Gives me an idea of what's popular and what's not. Helps me understand what topics people like. So
next, you want to limit connection and transaction lifetimes and use realistic timeouts when you're interacting with a database. In general, database connections should be as short-lived as possible, but no shorter, obviously. If it's impossible, then stuff is going to break. Long-lived connections that aren't doing anything are a waste of resources and a potential source of problems, right? Because if you've got a connection that's hanging out there, you very likely also have a transaction sitting on top of that that's not committed, which means you have locks.
Yeah. So you don't want to name your connections Methuselah or Lazarus Long.
Right. So the occasional Keith Richards connection is okay if you're in a long running process, right?
I mean, no, too soon. You should also have the same approach regarding database transactions. When you leave a transaction open for a long time while processing a lot of data, it's going to continue to eat up resources over time. This can also cause you to keep tables locked a lot longer than you really intend to, kind of depending on your database and how it works.
Right. And just like your strategy in general. Yeah, that's something I've seen a lot with junior devs that learn about transactions, and they'll be like, oh, I'll keep a transaction open for this whole thing and it'll be atomic. It's like, that's great, but you're spending like 2 hours to process 500,000 records. If you have to roll this thing back, it's going to be horrendous. And most of the time, you really don't need to touch that many records all at once. Most of the time, it's like you're batching something and you need to do it, broken down by, customer or broken down by some other thing. And those are individual units of work.
Mm-hmm. Yeah, I remember dealing with that with the file management system that I was working in a couple years ago. A year ago? It was about a year ago that I stopped working in it. So yeah, that's interesting.
Shorter connection timeouts are also really helpful. If your database is accessed by multiple applications, a shorter timeout will ensure that pathological applications will feel the pain of the issues they cause rather than other uninvolved connections. So if you're at the database server level, if you can say, hey, I don't allow connection timeouts of more than X, do that, or have some way of catching it with some kind of policy. Because what will happen is the worst performing applications tend to also be the ones that are written by people that don't understand the database the most. And those people will be like, oh, put like a 20-minute timeout on a connection, and their connection chews everything up, but their stuff doesn't break. Yours does.
Yep.
Been there, done that a few too many times.
It can be very tempting to just increase timeout length to avoid timeouts. But what happens is that this causes even more problems in other parts of the system. It can be done short term if you really, really have to do it and you understand the consequences. But you really should consider breaking up the work into logical chunks, handling it in a batch process during a time of low utilization, or doing the work on a system other than your OLTP database.
Right. So, one of the things I've seen a lot is people doing, really intense data processing operations on their, transactional database. And when you go and look, the work that they're doing is actually reporting work. They're getting things set up and they're trying to report out of that same database or shape the data before they send it over. It's like, maybe don't do that there, because that thing needs to be able to respond quickly. And the other one has different constraints on it. The next thing you need to always do is to limit the amount of data that is transmitted, usually by using paging, and obviously appropriate query criteria. With modern tooling, especially tools that generate SQL from another language, it's really easy for an unwitting developer to pull back a lot more data than they intended to. Such mistakes tend to not show up until the code's in production, because developers don't have that many records locally most of the time. And what happens is then you get these unexpected spikes in load for some, and then timeouts for others if it's particularly bad. And this can happen because you pulled back too many rows or too many columns, or both.
Yeah. That was like, do you remember, this was several years ago, but I took over an development of an application for a guy who was supposed to be a senior developer when he left. And he had been doing some stuff that looked really cool, and it taught me a lot. Like, I learned a lot from reading through his code about generics and stuff like that. But the way that the ORM was working, he was pulling back the entire table and then filtering.
Yep. We found one of those the other day.
And I learned, because he was passing a function. He was basically writing the function at his service level and then passing that into sort of a generic repository method that talked to the database. And I was like, that's really cool. And then I realized what it was doing. And I think the solution, I haven't dealt with that stuff in a while, but I'm pretty sure the solution was to wrap the function in an expression. So it created an expression tree.
Yeah. And then that gets converted into SQL.
That would get, yeah. And doing that fixed the problem. But I just remember that and was like, oh yeah, he had no idea, because he's working on the dev database. We didn't even know it until it got to test, or not test, UAT, because they had brought in some production data for for their people to work with. And yeah, which production data in UAT is iffy at best. But
yeah, I mean, I understand why that happens. I mean, the other thing I've seen is where somebody doesn't filter, or they're like, well, one thing that will cause this too is if you're doing things like search and you're building the filter dynamically. If you make the call to enumerate something that's doing the whole expression tree thing, kind of like we do in .NET, before you actually apply the filters, then you are going to pull back the entire record set.
Well, processes within the database, such as mass data updates, may need access to all the data from a table or set of tables at once. This is not very likely to be true for anything that is pulling data across a wire. Even large data exports can be paged. If they can't be, you are probably going to be struggling on your production system.
if you're pulling a lot of data, it becomes what they call a chunky call. These often have a lot of overhead going across the wire, and they can chew up a lot of memory on whatever is using them. Because you got to think how, like TCP/IP packets are broken up. There's a lot of stuff going back and forth. It's got to be sliced and diced and put back together on the other end. And you're basically loading it in memory probably until you can actually do something with it. And so it's just kind of sitting there.
Yeah.
This overhead really builds up pretty quickly, and it'll get you. Now, there's also the other extreme, which is what they call a chatty call. And a chatty call is like, oh, well, I want to break this up and I want to page this data. Well, I'm going to page it to 10 records at a time, but I iterate over those real quick. Well, what are you doing? You're sending a tiny instruction and getting a bunch of data back with all the overhead of transmitting the data. So you're still killing performance. You got to find a sweet spot between those two.
Fair. I'm just sitting here thinking about having a chat over some Chunky Monkey ice cream.
Having a chat with a chunky.
Not what I said.
That's what we all heard, Beach.
No, I said over some Chunky Monkey ice cream. Talking about some ice cream here. Speaking of ice cream, there's usually a sweet spot. Sorry, I couldn't help it. It's just the next line in Will's outline here. There's usually a sweet spot between pulling everything back and pulling one record at a time. If performance becomes enough of an issue, you may need to actually load test and tune this a bit. In practice, you can often get by for a good while with just kind of guesswork at it, though.
Yeah. Well, and the other thing, too, is a lot of times what you end up doing is you use the guesswork until the system gets enough utilization that it's actually worth hiring a real expert, and then it gets fixed. But yeah, a lot of times it's cheaper for quite some time to just guess.
So next, limit upstream load via queuing and by limiting concurrent connections. When processes get overloaded with work, the first thing to break is usually the database, because both licensing costs and kind of the way it is centrally located, the database plays a huge role in modern applications and is usually the worst scaling part of any system.
Yeah, and as a result of that, if you want your database to remain up, even if the system is under load, you're going to need to mitigate this issue before that issue hits the database. So when a service calls into the database, it needs to have its incoming workload managed by a message queue, probably, where possible, to keep a load spike from spreading to the database and from there to the rest of the system. So you're essentially doing flow control.
Yeah. Now, you may or may not be able to get upstream systems to limit their incoming work with a queue. You may also want to limit how many concurrent connections you will allow those systems to have. While the error messages that can result from this are not pretty, they do keep a poorly configured application from bringing your database down with too many connections.
Yeah, I've seen people that leak connections.
I have too.
And try to do a whole bunch of stuff at once, and they don't dispose connections properly because they don't understand how important that is. And they will starve your connection pool, essentially, where your database server won't respond to the apps that behave better because the app that's a piece of crap is basically ruining everything. It's what they call a tragedy of the commons. So like back in the medieval period in England, there was a time period where you basically had an area kind of in the village or around the village where you could graze your cows, but it wasn't anybody in particular's property. And so if everybody put their cows out there, the place turned into a muddy mess and there was nothing for the cows to eat. And so a person that was unscrupulous and did that with too many of their cattle ruined it for everybody else. Well, it's the same thing with database connections, except when you kill those, you don't get a steak.
Yeah, lose a steak.
Right. Well, you tick off a stakeholder, actually.
Yeah, there you go. I knew there's a way to involve steak in here somehow. Man, I could really go for a steak.
I could too.
Get some.
I know. I wish I had used that word.
I'm cooking chicken tonight, but All right. Anyway.
I got brats. So essentially then your client applications can either implement the nice thing that keeps them from overloading the system, or they can get the nasty thing that breaks their app if it's not a good citizen. While you'll get a lot of resistance on this one at first, it will eventually shape the behavior of your system's users so that they don't break the database as often in production.
So next, keep reporting concerns out of your OLTP system. When you first build a system, the database at the core of the system is the logical place from which to pull all the reporting data. However, as a system matures and scales, it becomes more and more critical to stop putting this functionality in the main online transactional processing system.
Yeah, I've seen this in a production database where there were a quarter of a billion rows in one table. And a client was mad because they couldn't do a full text search on a 2-character string in that table and get performant. Well, like it like hosed their entire system when they did it.
Yeah.
And it was their OLTP system. So like it stopped their business from running. And so you don't want to ever get to where you're there. So as you scale, you're going to want to pull the reporting functionality out into something else. It may be a actual reporting database. It may be that you build a blob and you shove that crap up to Elasticsearch, some kind of document database type setup. There's plenty of ways to handle this, but putting it in your OLTP system is going to hurt as you scale, and it's just going to get expensive. Reports are kind of weird because they're different than normal system load because they're often of very arbitrary complexity, and they often join a whole lot of tables at once. Reports also tend to become more complex and tend to be over ever increasing sets of data as time goes on. So somebody builds one that's like, okay, this hurts the system a little bit, but they don't run it often. And then they start relying on it and they want more out of it. And they do more and more joins and they do more and more filters. And eventually the thing will take the whole system down just because reporting grows like a cancer cell.
Yeah. Reports are also likely to be run when the system is pretty much already under a lot of load. Peak time for reporting is also peak time for the things you're reporting on.
Yeah. Unless you've just got some kind of really weird boss, they're not looking at, how many sales you made yesterday at 2:00 in the morning, right? They're looking in the middle of the day when those sales are happening.
Mm-hmm.
And so, if you want to keep everything streamlined and fast, that's a bit of a problem. Reports also tend to be kind of run in a bit of a bursty fashion. Certain days of the week, days of the month, and days of the year are going to see huge spikes in report requests, and these can often correspond with large bursts of traffic to the application, especially if your app touches financial considerations. So like the end of the month, first of the month, the 15th, whenever your company does their taxes. If you're in e-commerce, Black Friday is a good day for that. The last day of the year is also pretty good for that because of companies, trying to purchase things so that they can write it off on this year's taxes.
Yeah. Yeah. I was talking to a friend of mine about, I think my lawn game might be retiring in the next year or two. And, cause he's cutting back and, I didn't say that wasn't on purpose, but yes.
Sure.
Anyway, so I was saying, yeah, I'm probably going to have to buy a lawnmower because I'll just do it myself. And he was saying, oh, because that's what he does for a living. And he's like, best time to buy is end of the year, especially if you want something like semi-pro, because guys that started a business, they might have had it for 2 or 3 years and they'll sell their, nice lawnmower at the end of the year to get the tax write-off so that next year they can buy a new one.
Right.
So yeah, that makes perfect sense. So finally, use caching where you can. One thing that can really help with database resilience is to actually limit the use of the database. Caching the results of common queries relieves the load on the database for frequently used and relatively static data.
Yeah. So like anytime you got a lookup of something that doesn't change, put that crap in cache, as soon as you can, because there's no reason for that to be, transiting the network and or hitting your database.
Mm-hmm.
Now, your caching does need to be multi-layered, possibly to some degree using the user's machine. If you're on the web, you're going to be doing that anyway, like with GET requests, those get cached. You probably also will have a web server cache. You will likely have a caching service as well to handle different things. You may have caching at the database connection level. I know you were talking about you used in Hibernate. So you've got your first level cache on the connection, and then you got a second level where you can configure something like memcached or trying to think what the other option was that I looked at years ago. CouchDB, I think. These are things that you're going to want. And the reason is, you have different expirations for cache and different considerations around it. So like if you have a user that's pulling data back and they want to cache their data, not everybody's data. So some of the cache belongs to them, and HTTP actually takes care of that. That's one of the reasons we like RESTful endpoints as much as we do, is because there's all this other stuff built around it. Whereas your web server may need to cache things that are just frequently used by code that's running there. You may also want to build some stuff and cram it into cache, or use a document database as a cache in some circumstances, because you don't want to assemble some complex object from database tables. You actually want to shape it and get that work out of the way, so it's not happening on your database server or your app server on a regular basis.
Yeah. Also, if you cache a lot of things in a non-durable cache, you may need to rebuild them after deployments or as load increases, like first thing in the morning. If not managed well, this can load spike your database, even though your intent was to avoid load spiking.
Yeah, I've been burned by this a few times. The app spins up and it's like, okay, I'm going to pull back all the stuff that I cache on the regular so that the cache is hot. Well, that's great, unless that process does a whole lot of work, and all of a sudden now you've overloaded your database while that's occurring. So you are going to have to kind of think a little bit about cache duration and about when things hit the cache. Now, This will also get you if the shape of the data changes when you cache. So when we've put stuff in Elasticsearch, for instance, we have like versioned documents going in there. Well, when you go up a version, you got to take all the old data and move it to the new version. So it's not instantaneous to get it to shift, because it may be millions of rows. Does that make sense? How that would kind of, how that could blow up in your face if you're not careful. And from an architecture perspective, you should also consider whether you need up to the minute updates on frequently used data. A lot of times, even if you allow for an hour's delay on stuff being available for reporting purposes, that's a tremendous difference in the amount of load put on the database. Because it may be something like, hey, every hour or so we pull updates over to the reporting database, but we don't do it continually where we have to use the production OLTP database. Most business people are not looking at stuff up to the minute, right? Because there's too many variables going on. Like a transaction coming in for $500 right now. Yeah, cool. I saw that transaction come in, but there's some dunning logic going in there because their credit card's expired, or it was fraud, or something like that. And you really don't want it on the report until it's actually finalized, which typically is a delay from when it actually hit the system. So guys, databases are the most brittle part of many applications. Not only do they contain the most critical data for a system, but load management strategies for databases are always more complex than simply making another copy of data somewhere. A broken database can also break basically all the things. Even if you think your application is the only one that will use your database, over time, you'll probably find that this statement isn't entirely true. The database is often the easiest but not the most sustainable place to hook into the workings of an existing application, especially if one wants to avoid asking the team about it. As a result, having a resilient and robust database implementation is critical to application stability over the long term. Database resiliency covers a lot more areas besides just system administration tasks, and often has implications that reach well into the code also. So that about wraps us up. Beej, what do you have this week for us for tricks of the trade?
So in a lot of the points that we talked about, in basically the general summary of database resilience, was limiting or kind of keeping an eye on the amount of things, different things. And I just want to say this really applies beyond data transactions, but to most things in our lives. Really, moderation is the key to success in so many areas. A lot of times you can go to an extreme on one side or the other, and that's going to be bad or a rough time. For example, I was talking earlier about, getting close to my target weight. And if your goal is weight loss, you eat too little, you run the risk of undernourishment and possibly even developing an eating disorder. But you eat too much and you don't lose weight, you can even have like other health issues. The same applies to exercise, politics, and so many other areas. So I just want you to think about these kind of things like a road with very large ditches on either side. You go too far one way or the other, and you're off the road in a ditch. You want to kind of stay somewhere there in the middle. You can stay on one side or the other of the road, but you don't want to get too far, too extreme on one side or the other. And you do that by kind of keeping an eye on and limiting things. Now, guys, in the Aftercast, we're going to discuss some general topics of database stability and follow up with a discussion of some of the common areas where developers have database issues from an organizational perspective. That's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly Aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.